What's happening, all? Alright, so we've been doing a lot with fractions and factoring, and now we're going to talk about solving rational equations. Now, in the warm-up, we're going to recall some skills that we used to do, and we're going to recall solving by cross multiplication. Alright, so cross multiplying allows us to multiply across the equal sign, so to get 5 times x equal to 3 times 4. Alright, which gives us 5x equal to 12. Then isolate your variable to get 12/5. Again, just a friendly review of how to cross multiply. And as we move forward, things can get a little more difficult. Now, we have 3 times 9 equals x times x. 27 equals x squared. We square root both sides to get x equals plus or minus the square root of 27. Now, if I wanted an exact answer, you would break that down further. 3 and 9, 3 and 3. So x would be plus or minus 3 root 3. These should be second nature by now. All right, now over here, we would have 7 times 2 equals 3 times the quantity, x plus 5. So 14, distribute your 3. Subtract 15 to get negative 1. Divide by 3, so x would be negative 1/3. Now, when we get into rational equations, there's going to be one catch to this. Now, looking at this, remember when we found the domain first semester? So what would be the domain of this function? Remember, it's what value for x would cause the denominator to be 0. In this case, x would have to be negative 5. Now, or x cannot be negative 5, I'm sorry. So that would be the domain. Now, in talking about this, we're going to call this an extraneous solution. Now, right now, this is a very new topic for us today. So I'm just going to say before we solve each problem, you must calculate the domain. And our answer is not allowed to be this number. Now, in this case, we got x equals negative 1/3. But let's say we got x equals negative 3 and x equals negative 5, in which case negative 5 will not work because it's an extraneous solution. And tomorrow in class, we're going to take that more in depth, but we're going to look at graphs and explain kind of where this comes from. Today, I just want us to identify the domain and then move forward. If that answer comes up, it's not a solution. Okay? All right, so now, rational equations. So notice we're going to use cross multiplication to solve. But before we can do so, all right, we need to make sure we have a fraction equal to a fraction. So we're going to combine with what we did yesterday. Here we have a subtraction problem. All right, so we got to combine those to create one fraction before we cross multiply. So in this case, we're just looking at the left side of the equal sign for now. So my LCD is x and 2. So my LCD would be 2x. So this one's missing a 2, and this one's missing an x. So I get 6 minus 1 times x, which is x, all over 2x. And we're going to set that equal to 12 over x. Again, so I subtracted those two, found a common denominator, and subtracted the 2. All right, we should be getting pretty good at that. Now that we're set up like this, we're going to go ahead and cross multiply. All right, so when we cross multiply, I get x times 6 minus x equal to 12 times 2x. All right, distribute your x to get 6x minus x squared equals 24x, and we need to solve this equation. All right, so I'm going to get it equal to 0, but I want to make the x squared positive. So I'll move everything to the right side. So I'm going to add x squared, and I'm going to subtract 6x. So that'd be plus 18x. First thing I do to solve is look for GCF. In this case, my GCF is x. So I'm left with x plus 18 is equal to 0. Keep it over here. And then ZPP. So x equals 0. And x plus 18 equals 0. All right, so x is negative 18. Now, my two solutions are 0, negative 18. However, if we go back and look at the domain of this, okay, what can x not be? Well, we can't have a 0 in the denominator, so my domain says that x cannot be 0, in which case we have one here, so negative 18 is my only solution. And think about this. If you go to solve, if you go to check your answer, it wouldn't be true, because you would have, let's say, with 0, we would have 3 over 0 minus 1/2 equals 12 over 0. Well, you can't calculate that, so already that problem's at fault. Over here, if we did negative 18, 3 over negative 18 minus 1/2 should equal 12 over negative 18. And if you do the math there, it checks out. All right, so negative 18 works, in which case 0 doesn't. So when I say find the domain, that's what I mean. We're avoiding this, so when we get to the end, we already know. So looking at 5, let's identify the domain before we get started. All right, here, well, what would make this denominator 0 would be positive 1, so x cannot be positive 1. And over here would be negative 1. All right, so x cannot be negative 1. All right, so those are my two solutions that won't work. Again, we're really going to talk about this in class tomorrow, but it'll be a good conversation for us to have. I don't want to teach over video. All right, so the left side's good to go. All right, the left side's good to go because we have one fraction. Notice how I'm starting to the left a little because we're going to need some room. Now, over here, I need a LCD, in which case this is x plus 1. This has nothing. So my LCD is just going to be x plus 1. So the 4 is missing an x plus 1, and the other one's good to go. All right, so let's go ahead and simplify that before we decide to cross multiply. So the left's going to stay the same over here. Going to distribute my 4 to get 4x plus 4 minus 5 over x plus 1. And I'm left with, okay, so I'm left with 4x minus 1 over x plus 1. Okay, so I'm going to take it up here just to give ourselves some more space. And I have 5x times the quantity x plus 1 equal to x minus 1 times the quantity 4x minus 1. Now, I'm going to multiply this out on the left, distribute my 5x, and then over here I need to FOIL all this noise. So I have 4x squared minus x minus 4x minus 1. Alright. So I have 5x squared, I'm going to combine my like terms on the left there. 4x squared minus 5x minus 1. I'm sorry, that should be plus 1. All right, negative 1 and negative 1 give me plus 1. All right, so now I'm going to move everything to the left. So I'm going to subtract 4x squared because I need it equal to 0 in order to solve. That leaves me with x squared. I'm going to add 5x to get plus 10x, and then I'm going to subtract my 1. Now I'm equal to 0. All right, now two numbers that multiply negative 1, what? I can't factor that. So we must resort to the quadratic formula. So I get x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that leaves me with negative 10 plus or minus the square root of 100 plus 4 all over 2. So negative 10 plus or minus square root of 104 over 2. All right, you got to break down that 104, 4 and 26. 2 and 2. This be 13 and 2, so that leaves me there. So I'm left with x equals negative 10 plus or minus 2 root 26 over 2, which simplifies to negative 5 plus or minus root 26 as your two solutions. Alright, again, tomorrow we'll get into our extraneous solutions. In this case, those are my answers right there. Alright, let's try one more before this is all said and done. Alright, now, is this one ready to be cross-multiplied? Well, the left side is. So the left side's good to go. Now the right side needs some work. So here I have 6 over x squared minus 4. And plus 1, well, this GCF here is just missing an x squared minus 4. And it's just plus 1. So we're going to extend this. Sorry, I just wanted to look a little nicer. To go plus x squared minus 4. So we have 3x minus 2 over here times x minus 2 equal to x squared plus 2 over x squared minus 4. Alright, so I combine my like terms there. Now let's cross multiply. So I have 3x minus 2 times x squared minus 4 equal to x minus 2 times x squared plus 2. Now, looking at this, you could multiply it out, but it might make your life a little more difficult. Watch this little trick here. What do you notice here? Well, we have a difference of 2 squares. So I'm going to leave the 3x minus 2 alone. I'm going to have x plus 2, x minus 2 equal to this. Now, if you notice, I have an x minus 2 on each side. So if I were to divide both sides by x minus 2, that would get rid of that. So now I'm left with this on the left side, so I can FOIL it out. 3x squared plus 6x minus 2x minus 4 equal to x squared plus 2. Alright, so 3x squared plus 4x minus 4 equal to x squared plus 2. Let's get it equal to 0. Subtract x squared. I have 2x squared plus 4x. Subtract 2 minus 6. Now I need to solve that, so my GCF is 2. X squared plus 2x minus 3 equals 0. Two numbers that multiply negative 3 and add to 2. X plus 3. X minus 1 with the 2 out in front. So x is negative 3 and x is 1. So those are my two solutions. Let's go back and make sure they work out in my final here. Well, what would cause this denominator to be 0? Well, x cannot be 2. And in this case, okay, if I had x squared minus 4 as my denominator, alright, that's x plus 2, x minus 2. Well, we already know x can't be 2, so x cannot be negative 2 either. So in checking my work, that doesn't happen here. Alright, so do 7 on your own before class tomorrow. See what you can come up with. And remember, take a look at that domain, and we'll talk about extraneous solutions and do that one together. Make sure you got it correct. Alright, see you tomorrow.